Okay, everybody, this is Don Wedding. We're in Predict 411, and this is 2017, August of 2017, the summer quarter, and we are doing the office hours for our last and final homework, the wine problem. And we're going to open up the floor for general questions, but we had some before I hit the record button, and I'll address some of those as we go. We had one question from a student who wished to remain anonymous about R code. So one of the things that I'm going to do is I'm going to share a link right here in the chat window. So just a moment. And I'm putting together some very simple videos that I made for another class. And there's a link right there. Can someone click on that link and see if it will take them to a bunch of R videos that I put together? Would someone test that out for me while I continue to talk? So in the meantime,
I got the video verified.
Okay. It's not complete. I'm going to keep adding a few more, but this is at least a starting point right here. But what it is that so these are just some very basic types of things, but it's not going to be everything that you need. For example, imputing missing values, handling outliers, things like that, scrubbing the data itself. I haven't, these videos don't address that yet. I will eventually have videos on that topic as well. I'm just putting these in little by little. But this might give you a starting off point. Another thing that you can do, as I mentioned before the video, is you can always go to other students who are very skilled in R. There are students in this class who've forgotten far more about R than I'll ever know. If you can get them to assist you or give you some scrap code or some starting off code or really help you, that's perfectly fine. Just if you do it, say, hey, look, this is Joe, and my buddy Fred really helped me here. He gave me all this code, blah, blah, blah. And then if you do that and you put a big red box around that or, in your final report, what I'll do is if I look at it and I go, well, that's a lot of help, I might give Fred some bonus points because the best way to learn something is to teach. But I mean, if Fred just says, gives you the link to the CRAN repository or something like that, well, I could have done that. He's not getting any points. But if he really gives you some serious help, I'll give bonus points. I'll never yell at him for giving too much help. That's not, I've rarely encountered a situation where I thought something crossed the line and, the only thing you might get is a nasty gram, but that never happens. More likely than not, well, I mean, almost certainly I'm going to be very helpful. The guy's going to get bonus points. So does that, I'm hoping that you feel comfortable enough to, seek assistance from experts in this area. Does anybody have any questions about that? Okay. So then we had one other question. Lakita, you mentioned that you were curious about using Enterprise Miner. If you wanted to use Enterprise Miner and you wanted to use decision trees, did you have a specific question related to decision trees? I know you wanted to somehow put it back into SAS On Demand, but were you going to use it for fixing missing values? Were you going to do it? What was your usage? Because that will be
fixing the missing value.
Fixing the missing values. Okay, let me show you how to do that in the easiest possible way. Okay. I'm going to open up a diagram here, and I'm going to delete everything, but because I'm going to start from scratch. Okay, this is the home equity line of credit data set. I was playing around with this for other purposes, but let me delete all this stuff. Oh, I'm sorry. I thought I was sharing it. That was my first test of the day, and you passed that. There we go. Can you see my screen now?
Yes. Thank you.
Okay, perfect. Okay, so what I'll do is this. Okay, this is the home equity line of credit data set. Let me delete this guy too. And what we're going to do here is, let's just take a real quick look. This is the people we're trying to predict, the bad people, and we've got credit line age and number of credit line, debt to income ratio, et cetera. These were, from last assignment, this was the bonus problem. Is this completely unfamiliar to anybody? I'll just quickly show you what the data looks like, just in case you're curious. Okay, so the data itself looks like this. Bad people are people who don't pay me back, and that's got a 1. So this guy didn't pay me back. And you can see that I've got missing values in here, and I've got categorical variables, et cetera. Okay. So if I wanted to fix missing values using a decision tree, well, the best thing to do is if you come up here, there's a guy called modify, and if you click on that guy, and right here is a node called impute. So if you go grab that guy, and then what we could do is let's click on that guy, and I'm actually tempted to just bring the wine data set in here and just do it for you with wine. Would you like me to do that?
Sure, that'd be awesome.
Let's do it with wine. What the hell? As opposed to us actually doing this theoretically, let's just do it real. We're going old school, man. Okay.
I appreciate it.
Okay, so we're going to go over here. Let me see, 1 second. Okay, I'm going to stop sharing for a second. Not that I'm doing anything nefarious. It's just when I start moving around from directory to directory, I'm trying to not have my computer, when I got too many windows open, start slowing down. So I'm going to move some files around just a moment. So somebody asked me a question while I'm copying a file.
Ken, while you're in working with the wine, can you show us the filter mode or the filter node? I was trying to play with that today and couldn't get it to work. In the wine problem, we have we pull out the zeros and we have a second target.
Mm-hmm.
Is that what you
use?
The filter node?
Yeah, I can show you how to do that inside of Enterprise Miner if that's what your question is. Okay, let me try to share again. Did you guys want to take this down the path of Enterprise Miner today, or I don't want to. If there's people not interested in Enterprise Miner, I won't spend too much time on it. But let me tell you one thing before we commence showing you Enterprise Miner. Let's go over here to our class shell. So this is section 55. So section 59 looks identical to this. Okay, if you guys are interested, if you go down here a little bit to the recordings and you go to Poisson, if you click on this guy, what I'm going to do is I solved the wine problem here in SAS Code, and I even have the code itself that I use right here. So this video really goes into some pretty, clear details, and I think I solved this thing a lot of different ways. So this would be, pretty detailed, and I was going to go through something similar tonight if nobody had any questions. But if you want to use just vanilla code, I show you how to look at the data, how to scrub it, and we'll do it all with code. And I'll go through that tonight if you're interested. But I'm saying if this code is a really good starting point for you. Also, if you come down here, I solve the wine problem with Enterprise Miner, and I do it start to finish. So, you know, I've got some stuff here, and I show how neural networks can be used to simulate generalized linear models. But also, if you go back here to Home, and you come down here to Sync Sessions, and you come down to Special Topics, I have some stuff on Enterprise Miner, and I've got like a general overview of Enterprise Miner. I solved the Moneyball with Enterprise Miner. Here's the logistic regression, and here's also the Poisson. So, you know, this is, I really crawl into some detail here. These are worth looking at if we don't cover what you want to see tonight. But let's go back over here. Let's open up Enterprise Miner real fast. And let me hit the data source, create the data source. Let me just bring in wine really fast. Okay. Okay, so let's first of all deal with Lakita's question. Let's bring in the wine data set. And the first thing you do is you go to Utility, and you grab the Metadata Node, and you drag him on the screen. And this is where we tell Enterprise Miner what to, you know, what are the variables and what to do with them. So let me just hit Run. And the data will load from here into here, and this is where we tell Enterprise Miner what's the target, what's this, what's that. That's what we're going to do. Incidentally, the thing with Enterprise Miner is it's very similar to SAS in that there's like 8 different ways to do everything. So if you say, well, wait a minute, why can't I do this, you know, somewhere else? You usually can. I just recommend if you're going to define your variables, my recommendation is I only do it in a metadata node. The reason why I do that is because even though I can change these definition of these variables and drop them and all that in some other nodes, if I get a really complicated diagram and I've got like 30 nodes sitting on the screen and I'm like, where the heck did I drop that variable? If I know that I only do that in metadata nodes and I've got like 2 of them on the screen, I know where to look. So that's why I always recommend doing only things with metadata nodes. Okay. So I've got the data. It's going to go into here. I come over here and hit Train, click on the box, and here are all my variables. And if I highlight them all, we can explore them, and voila, this is the data, and you come over here and you can see I've got all of these you know, I've got some missing values, etc. So we're going to deal with this guy right here. So let's see. Whoops, didn't mean to do that. Open him up again. Okay, index, that's an identification variable. We're not going to use that. Okay, target, that's my target variable. Let's set him to target. Okay, asset index. Let's just look at these first 4 guys, see what they are. I think these are just continuous numbers. Yep, okay. So I don't have to do this. I mean, the default is that it's going to be treated as an input variable, but I usually like to make sure I actually set it, because then I know I've looked at it. And we know that they're interval variables. Let's take a look at density, fixed acidity, and free sulfur. Does anybody have any questions about the data while I'm doing this? Nothing? Come on, somebody's got to ask me a question here.
What does new role mean? Why is there role and new role?
Oh, okay. The role is what SAS, what the default is. This is what SAS takes his best guess as, okay? If I don't tell SAS what the role is, in other words, input, target, reject the variable, and reject means don't use it for anything. If you don't tell SAS, he'll use the default, which is this. But what I like to do is I like to purposely set these, even if the default is this thing, I like to go in and physically force it to be what I want, because I've got a reason for that. The reason is that if I set all of these guys manually, if I were to get a new data set, like the boss says, hey, listen, I want you to rerun your model with new data, and I pull a new data set on the screen and connect him in here, then if SAS guesses something different, then if I'm just using the defaults, then my model's going to behave differently, but I'm forcing it to always look the same. That means if I can dump new data in, I can always rerun my model with new data. So I would just delete this dude and then connect this new data set. It's the same one, but if it's new data, like it's been updated. So this is January data and this is February data. If I've forced every one of these guys to be an input variable or this or, if I do that, then all I have to do is connect the February data and hit run, and it's going to update. So does that make sense to you, whoever asked that question?
Yes, thank you.
Okay, so let's go back here. Let's just finish this up. We're almost done. Okay, so label appeal, I think that's a categorical variable if I'm not mistaken. And I think stars is also, I think both of these are just numbers like, 1, 2, 3, 4. Yeah, 1, 2, 3, 4. And label appeal they both seem to be ordinal. Like, so you can tell SAS a couple of things. Like you can say, okay, let's use this guy as an input variable. So the number of stars you get and the label appeal are both inputs. Okay. Now, then SAS says, well, what kind of thing is it? Is it an interval number? So that would be a 1, 2, 3, 4 or 4.2 or whatever. That's a number. Could be a binary. A binary is a true, false, yes, no, 1, 0, whatever. It's got two values. A nominal is a class variable like red, green, and blue. An ordinal is a class that has an order to it, like letter grades on a report card, A, B, C, D, F. And I'm going to say that the label appeal is either going to be a number or an ordinal. I'm going to treat it like an ordinal for right now. Well, you know what? We're going to just treat it as a number just to keep it simple. Okay. Stars also, let's keep that as an interval. Okay.
Is there like a rule of thumb that we could use if it's a number but there's less than 4 of them or 10 of them?
I would say that if the real rule of thumb is if like letter grades on a report card, there's a conventional wisdom that an A is worth 4 points and a B is worth 3 points and a C is worth 2 points and a D is worth 1. Okay? That's what people say. So you could just use 1, 2, 3, 4. However, it doesn't really, that's just something that people have decided on. There's no real reason to believe that an A is twice as good as a C. I mean, you might be in a class where the teacher gives out like, 1A and 500 Cs. Well, that A is worth a lot more than a C, twice as good. So if you've got a category and there's really no way of knowing, that the A is better than a C, but you don't know how much better, you can turn this into an ordinal, and then SAS will try to, treat it that way. So the rule of thumb is, my personal opinion is, if you can get away with treating it as a number, do it, because that's the easiest thing. And remember what I keep telling you, if you want to be an analytic street brawler, the trick is keep it simple, okay? So make your model as simple as you can get away with. This is as simple as you can. Now, if I start doing this thing and treating it as an ordinal, that's not as easy to implement. I can show you what the code looks like shortly, but it's not as easy. So I'm going to treat it as an interval for right now, okay? Residual sugar. See, SAS saw the word residual, so he says, hey, residual, this is some kind of an error. No, it's not. It's an input, so I got to change it to an input. And that's a number. And then also sulfates. Let's see, what's a sulfate? That's an input. I'm pretty sure that's an interval also. And I think these last three guys are all intervals. I'm not even going to look. You know what I'm going to do? I'm going to go back and turn this guy and this guy into ordinal variables. Well, heck, I'm going to make them just class variables for right now because I think that the code for fixing the missing values will be very simple that way. Okay, so I'm just going to turn these guys back to class variables for right now. Okay. So at this point, have I lost everybody? And when I hear silence, that means yes. But if somebody is everybody either A, bored, or B, lost? I need to know. I'm going to look at the chat window real fast. Nope,
No,
yes.
thank you.
Oh, Katie, what's the problem? Oh, I thought Katie has yes, she's lost. Or is that yes about something else?
Oh, that was yes about something earlier.
Okay, great. Okay, nobody's lost. Okay, great. Fully engaged. Monty, you are now my favorite student. Because he's fully engaged. Okay, let's go back here. Now, I'm about to do something that this is going to change your lives. Okay, everybody? Watch this. Okay, let's go up here, Modify tab. Come over here, Impute. Now watch this. I'm going to connect this guy. Now, Lakita, you want to do a decision tree imputation, right? Okay. We come down here, and we're going to do class variables. We'll do trees. And interval variables, we're going to do trees. And watch this. We're going to come down here, and it says indicator variables. Now, remember what I've been telling you guys all quarter long where I said, hey, sometimes the very fact that the data is missing is actually predictive. And then I say, remember that one episode of Sherlock Holmes? The dog doesn't bark, okay? It's missing data. The fact that the dog did not bark is important because the dog knew who the killer was. So the guy who was the killer was the dog's owner. And then I say, spoiler alert, because, that's kind of the joke because I told you the spoiler, then I said spoiler alert. Am I on mute? I'm not hearing any laughter on that joke.
I laugh every video. It's awesome.
There you go. Whoever that is, you're now my favorite student. Okay.
It's Tiffany, but you can give me some bonus points if you want.
Sure, Tiffany, I'm on that. Okay. So
and there was two options. You have imputed and missing for that indicator variable.
Right. So what we're going to do is we're first going to turn this to unique, which means that every variable that gets fixed will have an indicator variable. And then it could be imputed or missing. I like to have it as imputed, which means that the variable is set to 1 if we fixed it and a 0 if we didn't. If you turn it the other one, it's in the other way around. But a 1 means that we fixed it. The other thing we're going to do is change this thing, the role, to input. Okay, now at this point, Lakita, this node here is going to create a bunch of decision trees that will fix the missing values. And it's going to be a bunch of complicated code. This is what it's going to look like. So we're going to come up here and, we're going to run it. We're going to do one more thing. and before I run it, Lakita, we click on this guy here that says assess, and you come over here to this guy that says score, okay? Drag him on the screen, and we're going to hit run. Now hold on to your hats, everybody. This is going to be so, if you're falling asleep, wake up because this is going to be cool. So he's fixing this with a bunch of decision trees. And if you're going for bonus points, Lakita, just take a screenshot of this and say, Don, I got some decision trees.
Got it.
Okay, so he's building a bunch of decision trees to fix all of these wine variables. And now he's generating a bunch of standalone SAS code. Okay, now watch this. If I click on this guy, here's all the SAS code that will fix the missing values. Okay, and you're like, holy cow. You know how long it would take you to write this code if you had to write it on your own, Lakita?
Wow, that's awesome.
I am amazed. That is so cool.
Why'd you wait to tell us this now?
Well, I'll tell you what happened. Back in my days of when I was at Key Bank and Enterprise Miner first came out, and back in the old days, we had to write the score code by hand. But what happened was one day we get an updated version of Enterprise Miner, and this node is in here. And I was like, my boss says, you know, it used to be you'd have 6 months to write score code and debug it. And all of a sudden, I what's the score? Click. All of a sudden, it's like my boss goes, Don, you got 6 months to write this score program. And I look and I click this button, and 1 second later, I got score code, debugged, flawless score code in 1 second. So what I do is 3 months later, I go back to my boss and I say, hey, boss, you know the score program? I got it done in 3 months and not 6. And so he was like, holy cow, you're a genius, you know. That way, everybody wins. He gets it in half the time. I got a 3-month paid vacation. Everybody wins. Okay.
One quick question on this, Don, is when we're imputing values, like for instance, there are some cases where on the, was it the insurance one, right? You had good credit or bad credit, or you didn't have any credit marks against you, so you had, it was a null value, but because it was really a 0. Is it smart enough to figure that out, or is it just going to put the average of the credit scores versus somebody who just doesn't have credit?
Okay, well, this is how he does it. I'll show you what he's doing before we continue with this. This is how SAS will impute a missing value with a tree, okay? Let me just go over here. I'll show you what's going on with this. Okay, so what will happen is, let's say I want to impute the number of stars that you have. Like, you know, is this a 1-star wine or a 2-star wine, et cetera, okay? So what is going to happen is SAS is going to say, okay, we don't know how many stars somebody has. So the first thing he does is he comes over here and he says, well, here's our target variable. We're not going to use that. Okay, so he gets rid of the target. The target is how many bottles of wine we sell. He doesn't care about that. Instead, he comes over here and he says stars. That's our new target. Okay? So then all we're going to do is we're going to come over here and and he builds a tree. And the tree will look just like this. And he does this, you know, if we have 500 variables, he's going to repeat this process 500 times. But this is how he imputes the missing values. And I'll show you this real fast. And then I think this is going to answer your question, although you probably think it's not answering it. It is. I'll show you in 1 minute. So remember, I've got some missing values. okay, for the stars. So give me 1 second here. But we still haven't answered Lakita's question about deploying this code. Lakita, it's going to take about 2 minutes if we want to waste the first one, okay? But let's first go over here to this. This is our decision tree. So the decision tree of the people who are not missing, so if they're not missing, then 32% of them have 1 star, 37 have 2 stars, 23 have 3 stars, and only 6% of the wines have 4 stars. Then the first thing they do is they look at label appeal. Okay, if your label appeal is 0, -1, a -2, or it's missing, then this is the new distribution. You have a smaller number, a smaller percentage of 3-star wines and a smaller percentage of 4-star wines. But if you've got good label appeal, you can see the number of 4-star wines instantly jumps to 14, and the number of 3-star wines goes up to 32. Then we look at the alcohol content. If the alcohol content is small or missing, then you can see the 4-star wines goes down. Then so this is kind of how it works, okay? So what would happen here is, let's assume that we get a wine and we know that it's a 4-star wine. Well, if we know it's a 4-star wine, we just use 4 stars. But if we don't know how many stars the wine has, then what happens is the decision tree will go through all these if-then-else rules, and he'll go, okay, I've made it way, way, way down, right, I don't know, here. And he'll say, well, I don't know how many stars this is, but he has all of the, if he makes it to this bucket, 41% of these people have 3 stars. So I'm going to assume if you're in this bucket, you've got 3 stars. That's how this works. Or he comes down here, and you can see 45% of these guys have 4 stars. So if you make it this far, he'll make you a 4-star wine. Okay? So that's how this works.
Where is SAS getting those numbers? 78.15, 307, 8.
Oh, where do these numbers come? Okay, a decision tree is simply this. He looks at every one of the variables that you have. So in this case, we've got like 15 variables, and he does like 5. He takes each variable and he splits it in like 5,000 places. And he finds the very, very best place to split each variable.
Based
on, he has a metric. There's a couple of different metrics, but basically he's seeing which one will split these into 2 different looking buckets. If I separate the people in this class, and I separate them like left, and I say I want people to look different from one another, well, I could say like splitting them on left-handed and right-handed, but if I split people on left-handed and right-handed and then I look at them, I wouldn't be able, they look the same. Left-handed people and right-handed people look the same. But if I look at it and I go, well, the first thing I'm going to do is split on age, and I notice that old people look different than young, and then I'm going to split like on male and female, and I notice that males and females look different, and then I look at both, I say, okay, that's the best, one of those 2 is the best, and then I say, well, I think females and males has a bigger difference than old and young. So then we have old, we got females in one bucket, then we split them on old and young. We will never split them on left and right-handed because they'll always look the same. Same with men. Left-handed people, right-handed people, you can't tell if a person's like that by looking at them. Unless, I suppose if they were a baseball player and you have a baseball glove on, you know if they're left-handed or right-handed, but that's an unusual case. But did I answer your question?
Yes, thanks.
Okay, great. So we've got a million of these decision trees. Okay, now let's go back to Lakita's question. We've got this code. The only thing that this code is doing is simply fixing missing values. For example, I have alcohol, okay? If the alcohol so I copy alcohol into imputed alcohol, and then I'm saying if it's missing, then I go through all this logic to fix it, okay? And then he goes to the next variable, like over here, I don't know, where's another one? Free sulfides, okay? If it's missing, if it's not mixing, I don't do anything, but if it is missing, I'm gonna fix it. So he's gonna follow all this around. So let's go back to Lakita's question. What do we do? Okay, you hit Control A and you hit Control C. You've copied this. Okay, Lakita? Control A, Control C. Now, let's go over here and here is some code that I've just started working on before you guys came here. And this is just doing, this is just the raw data set. This is the same exact data set that we have. You can see I printed the first few guys here. And, you can see I've got some missing. What let's keep this really simple, Lakita. Let's only fix the stars, okay, so you can actually see. So I'm going to come over here, and I'm going to impute only the stars. Is that okay with you?
Yes.
I'm hearing. Okay. So let me click on Impute. I'm going to hit Edit Variables, and for all of these guys, I'm going to say my impute method is going to be none. So I'm not going to impute anything except for stars. So if stars is missing, then I'm going to do a tree. So he's only going to fix stars. Are you okay with that?
Yes.
Okay, great. So let's hit OK. It's going to be a much smaller program. So then I'll show you how we're going to do this. And if you do just this, Lakita, this would be fine. You can still get your bonus points for just doing one. It might be better to just do one because you can, or two or three, because it'll be easier for you to understand and look at what's going on as opposed to just copying and pasting a bunch of code. But let's continue this here. Okay, so let's hit Results. And you can see here, stars. I take the number of stars you have, and I dump it into here. And if it's missing, then I'm going to go through all of this logic here. And so let's see what this looks like. Control A, Control C. Now let's go over here and data temp file, set in file, run. Okay, now if I do a proc print data equals temp file, observations equals 3. This is just copying the temp files, right? Now, let's take that code and paste it right here. Bam. Now let's see what we get. Now you can see that I have the number of stars and then I have the imputed number of stars, but you can see that the number of stars was 2, so I didn't have to fix it. So it's 2, and I didn't fix it, so that's a 0. But if we printed a bunch of these guys, like, oh, I don't know, 30 of them, or let's do the first 30 of them. Let's see what we get. Okay. So you can see that over here, like right there, I have 2 stars. So the imputed guy, so I didn't have to fix him, right? And then that's a 0. But this one was missing, right? So because he is missing, I have to use my fixing code or my imputation code, and I filled it in with 1 star. And oh, by the way, I fixed it, so I'm going to put 1 there. This guy was missing, so I used my logic and put it in as 2 stars. And by the way, he's missing. So you can kind of see how this works. Does this make sense to you, Lakita?
This does. This made my night. This is really, really cool.
Isn't it though? Now, you could also use other tools like R or Angus or something like this, but the problem is with those guys, you would have to type in the if-then-else rules by hand, which is sometimes a very good exercise. But does anybody have any questions about what I just did here?
What's that warn column?
Oh, the warn column, this is just some diagnostic stuff. You know, the guys who write Enterprise Minor and they write this code, they've got all sorts of diagnostics that they append to the data set. And it doesn't do a darn bit of good for you, but this warn column is just, hell, I'm trying to remember what triggers the warning. Don't you worry about this and don't use it in your model, okay? If you actually look at Enterprise Minor, it will, in the score code, it appends lots and lots of extra columns that you as a practitioner will hardly ever need. And the warning, I don't even know what triggers the warning off the top of my head. And I've been using this tool since 2002, I think. So that's, closing in on 20 years. And I've never used this column. So that's why I can't even tell you with any degree of certainty what will set this thing to anything other than missing. But I'm sure one of the developers would say, Don, I use that all the time. Well, it's for developers and people like that. So punchline is don't use it. But who has that question? Because I don't like it when people ask me questions that I can't answer. It makes me feel, inadequate. And then you end up with, instead of bingo points, you end up, what's bingo spelled backwards? Ognib? Yeah, ognib points. You get negative bonus points. I'm just kidding. You know what? You ask me all the tough questions you want. Anyways, so does anybody else have any questions other than don't ask me questions that I don't know the answer to?
I have a question about that imputed stars column.
Right.
Is it imputing them when they are only missing, or is it all the numbers are actually imputed in there? I mean, it looks perfect for the non-missing ones.
Nope. He only imputes them when they are missing. If it's not missing, he just copies it over.
Copies of, okay. All right. Thank you.
So if you look, and let's just for fun, proc frequency data equals temp file, table, and then we would say stars, imputed stars, and M stars. And, oops, / missing, run. Now watch this. So stars, 26% of these guys are missing, right? Imputed stars, nobody's missing. And you can see we also got this guy. Just for fun, you want me to show you something cool, guys? Watch this. Proc means data equals temp file, class by M stars, So this thing is a 1 if we fix it, a 0 if we don't. Var target. Run. Print all types, and let's just do the mean. So look at this. The mean is the average is we sell 3 cases of wine. Okay? If I know how many stars you have, if it is a known commodity, then I sell 3.68 bottles of wine. But if I don't know how many stars you have, in other words, I had to guess, then I only sell 1.1 bottle of wine. Do you think that this is a predictive variable? Anybody want to guess on this one?
Definitely.
Yes, it is. This is one of these variables. It's highly predictive. This is one of the things that if you forget everything else I teach you in this class, remember to create a flag when you fix a missing value. Sometimes it is the best model you could possibly, or the best variable to put into a model. Credit, when you do credit scoring, the very fact that the guy does not have a debt to income ratio is extremely predictive. Why? Because if he doesn't have a debt to income ratio, he doesn't have a credit. You call up the Fair Isaac company and you say, hey, tell me about Don. And they're like, we don't know anything about him. Well, if you don't know about me, it means I probably changed my identification. It's a fictitious, I'm in there trying to get a loan and I'm not who I say I am. That's not a guy you want to lend $1 million to. So just the fact that you're better off lending money to a guy with bad credit. He's late a bunch of times on his bills. You're better off giving him money because at least he's late. He'll pay you sometime, as opposed to the guy who no one's ever heard of. Kind of reminds me of that episode of Batman from the 1960s, TV show with Adam West, and they ended up selling a nuclear submarine to the Penguin, and the Army sold him a surplus nuclear submarine, and it was to a Mr. John Smith, and it was a P.O. box. And Batman said to the general, I bet you there is no John Smith. And the general was really sad about that. Rent the movie. It's really funny. This is a funny reference. Somebody rent the movie and then trust me, it's funny. Did anybody see the Adam West movie, Batman? Nobody. Yes, very cool.
The TV show only.
Okay, trust me, it's funny. I saw the TV show. Okay, Francisco, trust me. Francisco, I want you to watch that movie with the one with it was the Batman the movie. It was the one where he couldn't get rid of the bomb. Okay, anyways. So that's about, so that's what we have here. Oh my gosh, we've almost been at this an hour. And I don't even know if I've accomplished anything. One other thing, as long as I'm teaching you guys stuff about Enterprise Miner, let me show you something else you can do. Let's go back here, and if you really want to get crazy, come up here to modify. So you go to modify, come over here, and there's a guide called variable transformation. Now watch this. This thing, now you can do transformations of your variables lots of different ways. However, here's one of them. And I'm going to change this guy back to default, okay? Okay, so he's going to fix all the missing values this time. Now, transformations, watch this. Click on this, and there's all sorts of different transformations that SAS will do for you, okay? And by transformations, we might do things like log transforms or inverse or put them into buckets or whatever. There's all sorts of stuff. And you're like, Don, that's really cool. But the question people say is, what's the best transform? Okay, the answer to that question is this. There's no way to know ahead of time what the best transformation is. The only way you can possibly know is to select best. And then SAS will go through and try every one of these things and see which one will give you the best transform. So let's go do that with all of our interval variables. Well, here, let's rerun this guy here 1 second. I was expecting a lot of oohs and ahs here, but I'm not getting them.
No, I'm doing that. I just have you on mute, but I'm totally oohing and ahhing over here.
Okay, I'm rerunning the Impute node, Lakita, so that you can, so I'm gonna fix all the missing values. Okay. I got a new chat message. While that's running, let's see what the chat message is. I love this node. I used it in my last assignment, and it really improved the model. Yes, it does, Katie. This is probably, short of fixing the missing values with a tree and that flag, this is probably the second best way to improve your model. So you've got this guy. Let's just update this guy real fast. And then we'll go over here with all of our interval variables, like acid, alcohol, fixed density. So we've got all of these guys right here, all these inputs that are intervals. And I'm going to come over here and I'm going to say, give me the best transforms. Okay, and I'm going to hit OK. And so then we're going to create the score code. So now, not only are you going to get the variables fixed using a tree, he's going to give you the best possible transformations. This is worth a try, but you're now adding a level of complexity. This is for people who are really close to 930 points already, or maybe you've already passed the 930. You know what? This is the time to start monkeying around with stuff like this. It can be very educational. So, if you're not doing so well, don't, if you get too cute, sometimes it really, you end up going down a blind alley, and it's better to get it done. Finished is better than perfect, so just remember that. So you can look, I've got all this code that fixes the missing values, and then we start coming down here, and then it starts putting things into various buckets or trying all sorts of different transforms, and there's no earthly way you can understand this code. However, it's going to be flawless. Control A, Control C. We come over here to our SAS code. We come way down here.
You didn't transform the target variable. We could. We don't want to in this case because of the...
You really don't want to do that.
Ever, or just in this case because we're going to do a log transform later?
I never like to say never. I try not to transform the target variable unless it's like something that has like massive outliers, like Moneyball. You sometimes had some of those baseball teams that played in like the 1881, and they played 3 games, and then Don Wedding comes in there and normalized it to 162 games, and then these guys ended up winning 168 games or something. Okay, then you might want to do a transformation where you say, okay, thou shalt never win more than 114 games or something like that. But, you know, I usually will not transform the target. Okay, so if I run this guy, you're going to see I've got a whole bunch of new columns. Okay, so I've got the target, and then I've got all of the raw variables, fixed, blah, blah, blah. Then I've got all the imputed ones, okay? And those are not even the ones you want to use. The ones you want to use are these guys. Maybe, you know, this looks a little bit complex, but he's putting them into buckets. And the buckets will be bucket 1, bucket 2, bucket 3, but these are the labels here. But let me see if any of them ended up to be like log. No, they all tended to be bucketed. So he put them all into buckets. But so anyways, this is probably a bad example because I wonder if I could print this without the labels. Oh, well. These things, if you look at the code, that should be like 1, 2, 3, or 4, but the labels say what the, you know, if it's less than 7.5 or, you know, in the range of 8 to 15 or whatever. This is, you know, like, for example, this guy here, he bucketed them here. Bucketing tends to be a very good way of doing it. So that's why bucketing tends to win. I think I just confused the issue. So, you know, unless you understood what just happened, forget you ever saw this. Anyways, now we had one other question, and this came from, I believe it was, who asked about splitting the data set? Somebody asked about.
I asked about filtering. Is that what you mean? The filter node?
Yeah. Don't use the filter node. Do it this way instead, okay? What I would do is this. Copy, paste. I'm going to show you a better way to do this. And let me just reload this stuff. Okay. Here's the best way to do this thing. Utility. Click on Utility. Come over here, grab a code node. Highlight the code node, come over here, Code Editor, click on it. And then you wait because it's slower than Christmas. And then you do this. Data, ampersand, enterprise miner, export, train, dot, semicolon, set, enterprise miner, import, data, dot, semicolon, run. So this will be the data that comes in, and this will be the data that we spit out. Okay? Now what we're going to do is create two new variables here. Actually, we could just do this. As opposed to filtering, let's do it this way instead. . let's just create, we could filter, but this is going to be simpler. Who asked the question?
It's Jason.
Jason? Okay. So here's what we're going to do, Jason. We're going to create a flag variable, and if the target's greater than 0, it's going to be 1. If it's not greater than 0, it's going to be 0. So do you understand this code right here?
Yes, I have it.
Okay. And then if you remember the notes, if you're going to do this, what we're about to do, you've got to subtract 1 from the target. And then that'll be the amount of wine we sell. So this will be, did you sell at least 1 bottle of wine? And if you did sell at least 1 bottle of wine, then we're going to build up. Now, why do you subtract 1 from this? It's in the notes, but the punchline is that we're building a Poisson model, and the Poisson model theoretically will have a 0 value. So we have to move everybody 1 to the left, and then we add this thing later on. I explain it better in the notes. The reality is, if you forget to do this step, the world does not come to an end, okay? It usually is very forgiving of this. But if you want to be a purist, subtract 1. So we're going to create, we've got a flag that's a 1 or a 0. A 1 means we've sold at least 1 bottle of wine or more, and then a 0 means we didn't sell any wine. Then we're going to create another variable called target amount. Okay, assuming we did sell some wine, how much did we sell? Okay, so what we're going to do is, these are the 2 variables. We're going to build 2 different models. Now, the last thing we do is, by the way, take this target flag, and if it's equal to 0, Jason, so you say if it's equal to 0, then take this guy and set him to null. Okay?
Got it.
Are you with me so far?
Yeah, I got it. Thanks.
Okay. So now watch this. Save changes, yes. Now we'll come over here and we'll run this guy. So now we're going to have 3 things that say target, but we're only going to use 2 of them right now. Okay, so now we're going to do this guy here. We're going to reject him. We're not going to use him now. And what we'll do is we'll start by saying, how much wine will we, or let's first of all see if we will sell any wine. So we're going to reject this guy here, reject him. So this guy here, the target flag, is going to be set to target, and it's a binary. Okay? And we can do anything we want. We could do a tree here. We could do a, let's just do a simple decision tree. How about that? And then we'll grab some score code here. So we're going to build a quick decision tree. Now, we could have used a logistic regression. There's a lot of things we could do. I'm just trying to keep this simple. And we're going to, well, all we're going to do here is just build a simple logistic model like we did last quarter or last unit. And there we go. Now, if we look at the tree, we've got a whole decision tree here that's going to predict the probability that you'll sell wine. Okay. We come over here. We grab the code for this guy. Don't take the optimized code, take the regular code down here. Control A, Control C. I think there's a reason I don't show students this earlier in the quarter. Because then you would never write another line of SAS code in your life. Okay, so right now we have a probability. This guy here, probability that the target flag is 1. That's right there. But we also have to say, what's the amount? So what are we going to do there? Let's go back to our enterprise miner. And let's come down here. And let's build a model for the amount. Now remember, the amount, if it didn't sell any wine, we set it to null. So this is only going to build us a model if they sold something. This is kind of like the car crash model. Okay, so we come over here, hit train. Target flag, reject him. And we'll come over here to the amount. We'll set this guy to input. Hit OK. And just for fun, let's go over here and fix. We're going to have to fix the missing values. So we're going to have to fix, you know, like the number of stars, and et cetera. So we'll come over here and count, mean. Let's just leave it like that for now. Unique input. And then let's go over here and grab a regression node. And let's make it a linear regression. And come over here and do a stepwise selection. And then we'll come over here and grab some score code. And there you go. Then we let nature take its course. So he's going to come over here, fix the missing values, except he's not going to fix the missing value for the target. Remember, the target is we're going to build a model to predict how much wine is sold if wine was sold. So the zeros, we throw the zeros away. We're not going to use those. Those are missing. Enterprise miner is going to see those missing. He's not going to use them. So now he's going to build, must use one target variable, huh? I thought I used a target variable. Oh. Target. Okay, let's try this again. So up here, we built a model that says, did I sell wine? And then down here, I said, okay, if I did sell wine, how much did I sell? So we're only going to use the records where there's one bottle of wine or more. So he's fixing the missing values. He's not fixing, you know, the zeros. We threw the zeros away. So we're only using when the amount was like one bottle of wine or more. He builds a regression model. Then he creates score code. And I think I'm running up against, I got a hard stop. We'll go 12 more minutes. I'm a little bit late, but. Okay, so SAS sometimes gives you optimized code. Don't use it. Just use the vanilla code right here. Hit Control A, hit Control C. We'll paste that code right here. So this is all the code that figures the probability that I sell a wine, and then after that, he fixes missing values, and he comes over here and he says, okay, if I do sell wine, this is how much I'm going to sell, the predicted target amount. So what's the total? P total will equal the predicted target flag 1. So this is the probability. Remember, that's the amount that we calculated up here from the decision tree. And then this is the probability we sell some wine. And then times, if we did sell wine, how much did we sell? That's this number right here, P target amount. But remember, we have to add 1 right back to that guy. Plus 1. And there you go. And then I can do var target, that's the true answer, and P total is our predicted one. And if you really want to get crazy, you could round this thing to the nearest 1. Okay. So there you go. He sold 3 bottles, we predicted 4. He sold 3, we predicted 3. 5, 4, 3, 2. Looks like a pretty good model to me. So there you go. Jason, did that help you?
Yeah, thank you.
Did it really help you? That did not sound like the voice of somebody who gets it.
No, I just wanted to know the best way to make those kinds of changes. I was really interested in the SAS Code node where we could make custom changes, because when I was looking at the filter node, it said user specify changes, but I had no idea how to make those. So the SAS Code node seems to work. Seems to be what
I'll show you. I'm going to give you the dirty little secret about Enterprise Miner, is that it was written by SAS coders for SAS coders, okay? And usually the best way to go is to go through a SAS Code node, okay? A lot of these nodes up here, like the filter node, where's the filter node? I think it's around here somewhere. Like, yeah, filter node. It's like filter node and some of these other nodes in here are actually like a replacement node. There's a replacement node in here somewhere. Interactive binning is a bad one. Replacement. Some of these things were designed for people who don't know how to write code. But because most of the people who use Enterprise Miner are coders, we instinctively jump in here where we have a total control. So some of these nodes, like replacement and filter, are actually not the best. They were not. They're used so infrequently by the real world that they're not as bulletproof and functional and beautiful as things like the tree and the impute and the regression. Those ones are great. These other ones like filter node, I've been using this tool for literally, like I said, close to 2 decades. And the only time I ever even used a filter node or a replacement node was if I was in front of customers when I worked at SAS, and they said, show me how to use it. And then I had to fix it or figure it out as I went along, because nobody really uses those nodes. The best way to go is what I just showed you right here.
Okay, thanks.
So does that help you? The other thing you could do is you could also, as opposed to doing this, you can also delete records as well temporarily. You could come over here, or not temporarily, but in one of the flows, you could do something like this. Here, I'm opening up the code node again. You could, instead of doing this, you could do if it's 0, then delete the record. And that's another way. That's the same thing as a filter, Jason.
Yeah, it's those little things that I thought would be handy to be able to do. Because the nodes are great, but I imagine at some point, once you get really good, they might be a little bit too rigid, depending on the problem. So.
Yes, and there's a lot of other cool stuff, but I'm crawling into the weeds more than I feel comfortable doing, because there's probably a lot of people that haven't been playing with this tool, and I'm afraid I'm losing them. So anyways, let me give a quick recap since we only got 5 minutes left. Then what I'm going to, okay, so we really focused a lot of enterprise miner stuff tonight for people who want to grab bonus points. Do anything with this tool, and I'll give you some bonus points, people. This is a great tool, and it's worth doing it. The quick questions that I get asked a lot, people say, hey, Don, I've got already 950 points. Do I have to do a write-up? No, you don't. You don't even have to do the last homework. I would be very sad for you if you didn't try to build the model, because this is a great learning opportunity, but this is your money. And once you got 930 points, you got an A, okay? So some people have done so many bonus points, they're already past the A mark, okay? If you're past the A mark, I would not do the write-up. I would just spend my time building models, trying new tools, playing around on the Kaggle competitions. Do that. Spend your time wisely, okay? You already know how to write a report. If you haven't got your A, do the report, because it's worth 150 points, okay? So that's a question, a frequently asked question. For people who want to not use Enterprise Miner, I would say here's what you're going to want to do. You're going to want to go over here to the course shell, and if you want to just do this, just brute force with code, and that's a good way to do it. There's nothing wrong with that. Come down to recordings, go to Poisson regression, and I would watch the first one. This is one I did from 2.5 years ago, and I walk through this thing, and I do zip models, and I do hurdle models, and I write it with code, and I fix the missing values. Oh, and by the way, here's your code. And if you don't like that one, here's another one. And then I do this one here. So I've got a couple of good ones here to watch. And I've got the code that I use, and I walk through it step by step. So this is another way to go through this stuff. If you want to learn how to use Enterprise Miner, again, you go back here, click on this thing, and where is it? Got some stuff on Enterprise Miner there. So anyways, those would be where I would mess around with. I mean, I've done these sync sessions so many times. I'm glad we took this in a different direction, but if you haven't looked at some of my previous recordings, and you just want to do a vanilla model, I've already done it ad nauseum, so I've already got that. So, or if you really are lost, you can contact me, and we can set up a time and talk. So before I end tonight, I'm an hour past, or a half hour past, and I'm sorry about that. But does anybody have any final questions, comments, thoughts? And as always, I answer questions on SAS, analytics, political prognostication, financial advice, and affairs of the heart. But actually, I don't do political prognostication anymore because I did not predict Donald Trump to win the election. So I was expecting him to lose. I'm not saying if I liked him or not, I just didn't think he would win. I'm hearing nothing, people.
Can I ask one quick question? To follow up on that email that I sent you the other day. About the macro.
Oh yeah. So the question about the macro is, incidentally, I can answer the question, but one neat thing is if you go back over here into one of the sync sessions, and I'll answer your question, of course, but I want to just show you that I had a student ask me about that last quarter.
I watched it earlier, actually. Okay. I had a question beyond it. It was
Go ahead.
different. At the top of the macro, you say, I think you call it score file. At the bottom of the macro, you call it temp file. Which is an input and which is an output? Does that make sense?
Okay. Sure. Let me take a quick look here. Fine. And I think it right here, zero inflated Poisson. I think that. Okay, so let me open up real fast. Okay, so what I do is this guy right here, this code right here. So this is the actual code. So the notes do not include this code, okay? Are you with me, Jason? Is this Jason?
Yes, this is Jason.
Okay, so if you look, this is the code that I provide for you with the notes, okay?
Right.
Okay, so I provide some notes and I also provide the code. Now the notes do not have this code. The code that I provide, starting with out file, is code that I have that generates a random fictitious data set. Do you follow that?
Mm-hmm. Yep.
Okay, so I create a data set that I'm going to use to build a model, and I call it out file. And out file is right here, and it's the amount of time people spend in the shower. Okay? So that's the first thing I do. Then, if you see, I copy out file into temp file. That's all I do. Right here with this code right here. Why do I do that? Because I've tried to get into the habit of telling you students, the first thing you always do is you take your data set, before you do anything to it, you make a copy of it. Because once you screw up a data set, you don't get it back, okay? And if you're pulling something out of a database and it takes you like 6 hours, and then you monkey around with it and you screw up some variables, and your boss, and you say, well, I'm sorry, I can't do any more work today, boss, because I got to pull the data again because I screwed it up. He's not going to be happy with you. So that's why I did this right here. So Jason, so I took out file and I copied it into temp file. And, at that point, I didn't really do anything to it, but, I might have done something like fixed missing values or whatever, okay?
Yeah, that's what I was trying to. So at the very end of the macro, it's you call a command to run the macro, and it says temp file. So I didn't know if the temp file was calling in an existing data set, or it was putting the calculated data in a file called temp file. I didn't know if it was an input or an output. Does that make sense?
Okay.
So that's the original data file, temp file.
That's correct. It's this guy right here.
Okay. And at the top of the macro, there's something called data. When you set the parameters for the macro.
Okay, let me see where that is. Right here.
Yeah. Well, you just had it.
Here.
Yes.
Okay,
Data.
yeah, right.
So find error data file, comma p. What is data file then? Is that a command or?
Nope. This right here is this guy here. Find error, and then I send him this guy, I send him this guy, and I send him this guy. Okay?
Okay, so data file doesn't really exist. It's just a...
Right. He just, when he catches it, the macro is calling him data file. Okay? So the macro, this guy, I'm sending him a data set called temp file. The macro, I throw him, he catches it, and he goes, well, I don't care what you're calling it. For my purposes, I'm going to call it data file. You call it whatever you want, but I'm calling a data file.
Okay, that makes sense. Thank you.
Okay. Does anybody else have any questions?
Hey, Don, do you have time to talk about the gain?
The gains. You mean the rock curve?
Yeah.
Yeah, I could talk about that. What's your question on that?
Okay, so I looked at you have the PDF and the Excel document.
Mm-hmm.
So here, it's just a really lame question, but
There's
so
no lame question. Go ahead.
I mean, I understand how to figure out the gain just looking at the graphs, right? Because I think it's kind of easy to see. But in the calculation, I just want to know, where do I grab the values to throw into the Excel file?
Oh, okay. So let me go back there real fast. Okay, so this is notes.
And if you have a video I missed or something, you can point me to that.
Okay. Well, here let me see 1 second here. This notes. I think it was week 5 where we did this. Okay, right here. So this was all the code that we had. Okay.
Right. Yep.
So this is the code that I do to create it. Okay.
Right.
So let me show
when
you.
I ran that. Yeah.
Okay. So he's using this data set right here. Okay, so if I actually browse it. So I predict this guy to have a 50% chance, but he's a 1, and I predict he had a 51% chance. This guy had a 2% chance, and he had a 0. And so this is, all I have here is what did I predict and what really happened. So that's the data set we're using, okay?
Okay, and then you just copy that into the Excel sheet?
No. I'll show you what we're doing. Okay,
oh,
so
okay.
We're starting off with this guy right here, and the only thing we need to do a rock curve or a lift chart or any of that stuff, the only thing we need is a data set with a probability and then what really happened. So are you so far okay?
Yep. Okay, and what really happened was the 0, right?
It was a 1 or a 0. This is the probability that you didn't pay me back, and this is, did you really pay me back? So this is what I think the probability is, and this is what really happened. So I need to know the probability and what really happened. I need those two numbers.
Okay.
Okay, now get rid of here. And this is as easy as falling in love. Trust me. Okay. So let's just go over here, and we're going to print it real fast. Just the first, I think I just printed them all. Okay, here's that same data set again. Okay? Are you there?
Yep, nope, I'm listening. Yep, following.
Okay, great. Just making sure you're getting it. So here I'm grabbing the data set and I printed it. Okay, the first thing I do is I'm going to sort this thing biggest to littlest of what's the probability that you didn't pay me back. So I'm sorting it. Okay.
Okay.
And then let's print it again. So all the big guys are at the top. So now the people with the really big probabilities are at the top, and you see most of them are ones. But every now and then I have a high probability, but they really aren't bad. But for the most part, and you can see as we go down the list, there's more and more zeros in there, right?
Right. Okay.
Okay. So now here's where it gets easy. Now we're going to run proc rank, and we're going to tell SAS to put it into groups, and we say we want 10 groups. I could put as many groups I want, but I'm going to say, listen, I want you to draw 10 lines through this data, okay? So he's going to do that, and now here's this guy. He's in group 1. Well, I only printed the first 10, but let me see if I'll print them all for you. And then I'm, okay.
Yep. Okay. So we should see different rank values.
So that you can see I've got, this is bucket number 1, and this is bucket number 1 is the best bucket.
Right.
And I come down here and suddenly I get bucket number 2 and bucket number 3.
This is like the grading exercise, kind of. Okay.
Well, kind of. He's just, yeah, he's just, you know, he's just, well, no, this is, he's just basically, he's rank ordered the probabilities from big to little, and now he's putting them into buckets, 10 buckets.
High, medium, low, right? Like, okay.
Okay. So now he comes over here and he says, now I want you to tell me how many times did we have for each of the buckets so there it is. So now he's running it, and now he says, okay, in bucket number 1, we had 605 people, and 570 of them were bad people.
Okay.
Bucket number 2 had 605 people, and there was 343 people. Do you follow that?
Yep. And then I see the cutoff value where they move to the
Yep.
next. Okay.
Yep. And then so then we just take this guy here, and where did it go? Week 5. Okay. Then we just go over here to gain this guy right here. Open him up. This is why it's as easy as falling in love, because all you got to do okay, you come over here and where the heck was it?
Well, there's your cutoff on the observation numbers.
I'm trying to think where I wanted to put this stuff. I think I put it right here. Yeah, right here. So all you're going to do is you're going to just simply put cumulative response, then the ellipse curve, rock data. Yeah, okay. Go over to this first guy right here, and you see where this guy here is for group 1, 7881. And then you just put in 7881 there. Then you put in 570 and 605. And you put them right there, there, there. Then you put the next group in here, here, here. And just fill in all 10 of these guys, and the curves get written for you.
Okay. And the total observations, total TP, random TP. What about those?
He calculates them for you.
Ah, they're calculations. Okay. All right. Forget it.
You,
Okay.
The thing you have to do is fill in these guys. The
Okay.
rest of it's for you.
Well, that's easy. All right. I'll totally use that. Well, I understand this is super valuable for marketing. That's why I didn't want to make sure. I want to make sure I understood what was going on here. My understanding, this is something people do a lot of for the marketing predictive analytics
Oh, yeah, it's huge.
for channels, right? When you're evaluating your channel spend.
Yep, that's exactly. It's a million. This is a good skill to have. If you forget anything else in this class, remember the ROC curve. Well, the ROC curve and the flag variable for missing values. Those two things. This is like that Monty Python skit with the Spanish Inquisition, you know. Google it. It's funny. Okay. Anyways, so this is Tiffany, right?
Yeah, no, thank you so much, because I just read an article about this and I'm like, oh, I better make sure I get this.
Okay. So this is for this, and there's, this is if you want to come back and look at it and then ask me more questions, give me a call and we'll walk through it a little slower. But this is how you do it.
No, I think that was pretty easy. So if that's all you got to do, that's pretty straightforward. I know I ran the SAS code. I just was silly enough. I couldn't figure out which values from the table I was supposed to grab. That's all.
Okay. Well, I'm at a hard stop, people, so I got to let you go. Is there any other final questions? If not, I'll post this sync session probably tomorrow.
This is great. Thank you. Thank you, Don. Thank you so much.
Hey, Don, I have one last question. Well, actually, it's
sure.
not regarding the homework, but it's about the grading. Did you already grade the scored test data set for Unit 2?
Yes, I did. If you didn't get a grade, either I forgot to mark it or I didn't get your data set, send it to me and I'll score it for you.
Okay, I'll send you an email. Thanks.
Okay, fair enough.
Hey, Don, this is Curtis. What time are you open for a call?
What time am I didn't hear your question. I'm sorry.
What time could you take a call tomorrow?
It would probably be in the early part of the morning because I'm going to be driving most of the day. So if you give me a call around, maybe 9 o'clock in the morning. If not, give me a call on my cell phone. You got my cell phone number, and I can talk to you while I drive. And
sounds great.
We could do that too.
Okay, sounds great. Thanks.
Okay, be good, guys.
Thank you.
Thanks.